Swayam Prabha. Digital India. Educated India.
Next, what we want to see is the deflection of the beam. I want to find delta y. Next, I am interested in finding delta y. Okay. We add the governing equation d square delta y by dx square to be given by mz by E times I z z, right, from the bending equation. Now, mz we know is w by 2 into Lx minus x square divided by E times, for the rectangular section it is bh cube by 12. Okay. So, this becomes w by 6 w E bh cube into Lx minus x square. Okay. Now, I have to integrate this equation twice, which means delta y would be 6 w by E bh cube into L into x cube by 6 minus x power 4 by 12 plus c to x plus c3. Okay. That is what I will get if I integrate that equation twice. From the boundary condition, I know that delta y at x equal to 0 is 0, delta y at x equal to L is 0. Okay. Hence, I use that boundary condition, delta y at x equal to 0 is 0 implies C3 equal to 0, and similarly delta y at x equal to L equal to 0 would imply L power 4 by 6 minus L power 4 by 12 plus C2 L has to be equal to 0, from where I get C2 to be minus L cube by 12, right. Okay. Now, then delta, substituting these values in delta y expression, delta y becomes 6 times w by E bh cube into L x cube by 6 minus x power 4 by 12 minus L cube x by 12. Okay. This I can rewrite it as minus w by 2 E bh cube L power 4 x by L power 4 plus x by L minus 2 times x by L the whole cube. Okay. So, now what am I interested in? I am not interested in just finding delta y, I want to find delta y max occurs where and what is its value. Okay. Now, to find delta y max, I have to set d delta y by dx must be equal to 0 to find where delta y max occurs. Okay. So, d delta y by dx would be minus w L power 4 by 2 E bh cube to 4 x cube by L power 4 plus 1 by L minus 6 x by L cube. This has to be equal to 0, which means I get a cubic equation here, x cube 4 plus L cube minus 6L to x equal to 0. Okay. This cubic equation has various possibilities, can result in 3 real roots or 1 real root and 2 complex roots. Then I pick the real root, becomes the location. On the other hand, if I add 3 real roots, what will happen is there will be only one root which will lie in the domain of 0 to L, because I am looking at a solution for this equation in the domain 0 to L. Okay. I want to solve, say this is equation 1, solve equation 1 for x lying in the domain 0 to L. Okay. You can see now by inspection that x equal to L by 2 is a solution for solution 2 1. Okay. It is a solution 2 1. Let us substitute and find out. X equal to L by 2, it will be 4 by 8 plus 1 minus 3 by 2. This is 1 by 2 and this is 0. Okay. Hence, x equal to L by 2 is a solution to 1. We will use that. So, delta y max occurs at delta y at x equal to L by 2. This, going back to our equation, would be minus W L power 4 divided by 2 E B H cube into 4 times 1 by 2 whole power 4 plus 1 by 2 minus 2 times 1 by 2 the whole cube. Okay. So, this will be equal to minus W L power 4. I reintroduce I Z Z. So, this will become 24 E I Z Z, because it is by 12 multiplied by 12 into 1 by 16 plus 1 by 2 minus 1 by 4, right. Okay. So, this will be nothing but 5 by 384 W L power 4 minus E I Z Z. Okay. This factor, if we take LCM as 16, will be 5 by 16. 4 plus 2 6 minus 1 is 5 by 16. Okay. So, that is what it will be. So, delta y max is this. Okay. Now, why is delta y max negative? That is the question we have to answer next. Delta y max is negative because you assume the positive y direction to be on the top, whereas the beam is deflecting at the bottom. Okay, it is moving in the negative y direction, that is why it is negative. Okay. And the maximum deflection is 5 by 384 W L power 4 by E times I Z Z. So, delta y max is minus 5 by 384 W L power 4 by E times I Z Z is negative because it is deforming in the opposite direction to the assumed positive y direction. Now, let us plot how the deformed shape looks like and how the slope of the deformed shape looks like for this simply supported beam. Okay. Subject to a UDL. We found that delta y is given by W L power 4 by 24 E times I Z Z into x by L whole power 4 plus x by L minus 2 times x by L the whole cube. Okay. So, it is a 4th order polynomial, okay, and its deformed shape would look something like this. Okay, where the maximum bending moment will be 5 by 384 W L power 4 by E times I Z Z occurring at a distance of L by 2. Okay, and that is the location where the slope will go to 0 also. Okay. Now, let us plot the slope. Theta is d delta y by dx, that is W L power 4 by 24 E I Z Z into 4 x cube by L power 4 plus 1 by L minus 6 x square by L cube. Okay. So, this will be W L cube by 24 E I Z Z into 4 x by L whole cube plus 1 minus 6 x by L whole square. Okay. Now, what is this theta? Theta at x equal to 0 is W L cube by 24 E I Z Z, and theta at x equal to L would be minus W L cube by 24 E times I Z Z, right. Why is the sign of theta varying from x equal to 0 to x equal to L? Okay, that is the question. Now, if I were to plot this cubic equation, and you know that theta at x equal to L by 2 is 0, it is a continuous function. So, if there is a 0, the sign has to vary from positive to negative. Okay. So, this is a cubic equation. So, this curve would look like something like that, okay, and this value is W L cube by 24 E I Z Z, and this value is also W L cube by 24 E I Z Z. Okay. Now, here I have drawn it flat here, because the next derivative of the bending moment here is 0, and bending moment m z is d square delta y by dx square, that is the curvature. Okay. So, d square delta y by dx square is at x equal to 0 and x equal to L is 0, that is why the curve has a 0 slope at its two ends. Okay. At ends A and B, the slope of the slope curve is 0, because the bending moment is 0 at A and B. Okay. So, that is how the theta slope will look like. So, this is delta of y, this is theta, the slope diagram, and this is the deflection diagram. Okay. Okay. Now, what is left? We haven't still looked at the shear force, right. So, now let us look at the shear force. We just saw that Vy, we saw that shear force was W by 2 into L minus 2x, right. W by 2 into L minus 2x is the shear force with a negative sign there. Okay. That is the shear force. Now, what is the shear force going to produce? The shear force is going to be produced because there is a sigma xy stress, right. Now, how does this stress vary across the depth? This stress is produced by, this shear force is produced by the stress sigma xy. So, the question we have is, how does sigma xy vary across the depth of the cross section? Cross section is a question. Okay. Clearly, you know that at top and bottom surfaces of the cross section there is no complementary shear coming in, because in the y plane we said that only sigma yy stress acts, hence it has to be 0 at those two locations. So, it should have some variation along the depth to be given by. So, if this is the cross section, you know that this is 0 for sure at these 2 points, and hence we will see in the next class that it will be a parabolic variation like this, with the maximum shear stress tau max being 3 by 2 V by BH. Okay. We will see this in the next class, and what we have seen is we have analyzed a simply supported beam subject to a uniformly distributed load. We found the bending moment, the shear force, the deflection, the rotations, and then we are yet to find how the shear stress varies across the depth, but we found how the bending normal stress varies across the depth. Okay. That is all for today. Thank you.